All right, let's jump right in. You know the feeling, right? The pager goes off, customers are hitting you up on Twitter, and your most critical API has just slowed to a crawl. It's that high-stress, all-hands-on-deck race against the clock. Well, today, we're going to crack one of these cases wide open, turning a complete mystery into a clear-cut, step-by-step investigation.
So just imagine it. This is happening right now. The pressure's on, your whole team is looking at you. What do? Do you just start yanking logs from random services? Do you restart a couple of pods and, just hope for the best? What is that first absolutely crucial step? Because honestly, the answer to that question is what separates a long, painful outage from a super quick, data-driven fix.
And this is really where our mystery begins. Because before we had the right tools, answering that question it felt like you were a detective fumbling around in a pitch-black room. You know a crime has been committed, the system is slow, but you've got no light, no fingerprints, absolutely no clues to go on. This was the old way of debugging, and it felt a lot more like guesswork than engineering.
I mean, this was the reality, wasn't it? You'd start by just guessing which service might be the problem. Then you're in the terminal, running kubectl logs, and just getting hit with this massive, unfiltered fire hose of text. You're just sitting there, grepping for keywords like error or timeout, totally lost in a sea of data from dozens, maybe even hundreds of different pods. It's slow, it's stressful, and it burns through precious time when you have none to spare.
And when you put them side by side, the difference is it's night and day. On the one hand, you have total chaos, guessing, grepping, and basically just hoping you get lucky. The result? Sky-high stress and a resolution that takes forever. But on the other side, you see a completely different world, and that's the world you get with a service mesh. We start with clear signals, we follow a logical, data-driven path, and we nail down the issue fast. It's a total shift from frantic searching to methodical investigation.
So the big question is, how do we get from that chaotic guessing game to a structured investigation? Simple. We turn on the lights. And in a modern microservices world, that light switch, that's the service mesh.
The best way to think about a service mesh is like a dedicated traffic control system for all the little highways inside your application. It sits right in the middle of all your services and directs how they talk to each other. Now, it does a lot of cool stuff with routing and security, but for our detective story today, its real superpower is observability. Because it sees all the traffic, it can automatically generate the clues we need to solve our mystery. And get this, without us having to change a single line of our application's code.
And the very first clues the mesh hands us are these, the golden signals. Think of these like the vital signs for your entire system. Is something feeling slow? Check latency. Is a service totally overwhelmed? Look at traffic and saturation. Is stuff just failing? Check the error rate. These high-level signs are a starting point. They tell us where to even begin looking in this giant haystack.
All right, we've got our toolkit, we have our first set of clues from the golden signals. So let's put on our detective hats, let's get back to our slow API problem, and start following the evidence.
So, what's our first move? We pull up our per-service latency metrics, and boom, the evidence is literally staring right at us. The user service and the inventory service, they're lightning fast, well under 100 milliseconds. But look at the API gateway. It's taking almost a full second. We haven't looked at a single log file yet, but we've already narrowed our search from the entire system down to one single service. That is huge.
You see, what we've just done is the first part of a repeatable playbook. Step 1, check those golden signals at a high level. Done. Step 2, use those metrics to isolate the problem service, our API gateway. Check. And now for step 3, we need to look inside that service to find out why it's so slow. And for that, we're going to need our next tool.
This is such a crucial point. Our metrics were like a smoke alarm. They did a great job of telling us, hey, there's a fire. They even told us which room the fire was in, the API gateway. But to actually put out the fire, we need to know exactly where the sparks are coming from. And that's the job of a distributed trace.
And this right here, this is the aha moment. This is what it's all about. We pull up a trace for one of those slow requests that went through our API gateway. And the trace gives us this beautiful step-by-step waterfall view of every single operation that happened. And right there, one call just sticks out like a sore thumb. It's taking way longer than everything else. It's a specific, gnarly database query. We've just gone from a vague, system-wide slowness problem to the exact line of code causing it, all in just a couple of minutes.
So there we have it. We've found our culprit. The case is officially closed. The fix can be deployed, and the API is zipping along again. But what do we need to pack in our observability go bag to make sure we're ready for the next mystery?
Okay, so here's the essential checklist. First, you absolutely need those high-level, per-service golden signals. Then, for trickier network stuff, you'll want deeper Envoy-level metrics. Most importantly, though, you need distributed traces that are context-propagating. Now, that's just a fancy way of saying that each step of a request carries a unique ID with it, so you can follow its entire journey through your whole system. And finally, none of this is useful if it's not plugged into the dashboards and alerting tools your team is already using every day. So we've seen how having the right tools can completely transform a frantic, stressful firefight into a calm, methodical investigation. The service mesh, it basically gives you a detailed map to your system's performance. So the only real question left is, now that you have that map, what hidden bottleneck, what lurking issue are you going to find first?